Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the process creation in the process management, how the processes are created, including the init system call, how the tree of processes generated. In the Unix and Windows, both are here, the processes are created in which ways. During the process of execution, a process may create another process. The creating process is known as the parenting process, and the created process is known as the new process. Now, the new processes in turn can create more other new processes, forming a tree of process. Now, the tree of processes, each process is called a PID. This PID identifies the process with a unique identification number, mainly an integer value. This integer value is then used to index the PID in the system and inside the kernel. This way, PID can help in indexing the tree of processes. Now we will see that in Linux and Unix, how a tree of processes is created inside an init process. The init is the root parent process. It is a user process of the tree of processes. Inside that, we will create or help the children of this init process. This can be login, the kernel thread, and the pthread processes. Let us see. Here we have created three processes as the child process of the init. The first one is the login process, which manages the login of user directly into the operating system. It is then can use a bash shell, which then can use many other commands like ps and exec commands. Here you can see that every process is given a process name as well as a PID in the tree of processes. So the login process is maintaining the logging on of the user into the operating system. Here we are using a bash shell, and the ps command will list the directory of current processes in the system. The command ps-xlfp will give us the list of the directories that are inside the bash shell of that operating system. This way, the bash shell and the ps can be the child processes of the init process, as well as the ps is the child process of the bash shell. Now we will see that how kthread and sshd process is helping us. The kthread is managing all the processes that are created outside the kernel to help in behalf of the kernel. This can be, there are many processes, khelper process, and there are pdflush process. Now the SSHD process is for managing the users who are currently logged on into the system using the SSH processes, that is a secure shell process. This secure shell process enables the user to use all the processes and the subroutines in the operating system present in an user directive manner. So the SSH process again can have a child process named as a trench or any other processes. Here we are mentioning trench as the child process of an SSHD process. As you can see that all the PIDs mentioned to the processes are all unique integer numbers that can be identified by your process only. These processes are then formed into the tree of processes which can be indexed into the operating system to help the communicate with other processes. In general, When a child process is created by a parent process, then it may need some resources such as CPU time, available of list files, and any other resources that can be provided to it to consume its operation. Now these resources it can obtain directly from the operating system, or the parent process can restrict it by consuming its own resources to the child's. And the children process can then again share the process's resources among them. The sharing of resources can be restricted to only parent process. That is why the child processes cannot entertain any other child process to achieve the sharing. Now, along with sharing and obtaining resources from the parent process must also give the data initialization part to the child process. It gives us some initialized data of the resources using to the child process. For example, if a user process is using the processing execution to contain the delivery of image.jpg to a terminal of the screen. Now the parent process should give the child process the name of the file as its parameter, the data initialization, and also the terminal name as an output. Now the child process will have the data initialization part already inherited from the parent process so that it can execute its consuming operation. The child process, if it obtains from the operating system the data initialization part, then the operating system would have given two parameters to the child process directly, the name of the file and again the terminal name. Then the child process could write the content out of the file and then place it into the terminal of the screen. In this way, a child process can execute with the resources and the data initialization part with the help of inheritance from the parent process. Now, when a parent process is creating a child process, then two possibilities can occur. The parent process is executing concurrently with the child process, and the second one is the child process terminates. After the termination, the parent process can resume its operation. And in the address space, there are also two possibilities. The child process is having the same address space, that means the same data and the information and programs as the parent process. And the second one is the child program is loaded into a new program in its address space. Now, when the parent process is creating a child process using a fork system call that is usually used in the Linux and Unix systems, can create a new child process using the memory of the address space of the parent process. Here it copies the memory of the parent process to the new child process's address space. The only difference between the fork system call of a parent process and a child process is the return of the fork system call for the child process is 0, whereas the return of the fork system call for the parent process is a non-zero. That is actually the PID or process ID of the child process. After the creation of process by the fork system call, one of the two like parent process and child process must execute a exec system call to actually execute a file into the memory. The exec system call by the new child process or the parent process loads a binary file into the memory, erasing all the contents of the address space memory of the process that is being executing and starts execution of that binary file. The difference between the exec system call in the parent process and the child process is that it can go in separate ways. The parent process can consuming the request for the processes creating the child one, and the child process can executing the actual file. Sometimes the parent process has nothing to do with the operation of wait system call to get it off the ready queue until the child process terminates. After the child process has finished its execution and deallocated all the resources, then the parent process can again resume its operation. Now we will see the help of the fork system call how creation of a process is done. First, we are structuring an instance of the PIDT, that is a creation of process ID, as an instance PID. Now this PID is getting the system return call from the fork system call, that is actually creating a child process by the parent process. See, if the PID has got a non-zero value and it is negative, then the creation of fork has not completed. Here we are displaying a standard error message that the fork failed, and the error message is returning an integer number to the system so that it can identify the fork has failed and the child has never been created. Now, as we know that the fork system call returns a PID of 0 for the child process. Now, if the PID is equals to 0, that means it is the child process. So, we are using the exec LP, that is a version of the exec system call. Here, we are using the bin_ls parameter to the exec LP system call, which is a version of the exec system call. This bin_ls is actually the directory name of the file name that is to be passed to the child process to execute a listing of the file of directories inside the bin file. Now, if the PID is returning a non-zero number and that is positive, that means it is actually the parent process. So what is the parent process doing here? It is waiting for the child process to terminate its execution, and after the completion of the execution of a child process, then the parent is resuming its operation. And the printf comment here is for displaying that the child has completed its execution. So in this way, the fork system call can create a process in Unix and Linux-based command. The call to the exec command or the system call overlays all the memory spaces of the parent or child processes and included the loaded new program. That is why the control cannot return to the system until an error occurs. Now there is no way to prevent the child process to other than executing the parent process's address space as the new process, and it can be executed only in the parent process's address space. So to avoid this one, in Windows how we can see that created the processes is done. Now before going to the Windows command system, we will see by a diagram that the how fork system call is creating the waiting call for the parent process. So here the parent is creating a child process using the fork call, and if the PID is equals to 0, then the child is executing, and on exiting the child process, it is the returning waiting call for the parent, and which is then resuming the parent's operation. Again, the parent can go wait for a PID is greater than 0 if the fork call returns. If the fork call returns PID is greater than 0, then it can go directly to the wait call. Now by this way, the PID can go to the wait call, and after the finishing of the execution of child process by exit call, it can again go to the wait call, and after only the parent can resume its operation. Now we will move into how Windows can create a process using a create process command. While we are creating the process in a Windows system, there are mainly two structures that to be concerned with. One is the start of info, and second one is the process creation or process information. Now the instances of these two structures must be added to the program to get information about the processes. The startup info instances can give us the information of various attributes of the process, such as the size and appearance of the windows in the processes, the handle to the standard input and output. And the process information can give us the information like the handle and the inheritance to the process, new process, child process and its thread. Zero memory function is there to allocate the instances memory for these two structures. Now the fork system call in Unix is as same as a create process system call in the Windows. The create process in Windows can create a process by giving the parameters of none less than 10, where fork system call was passed with no parameter. Again, the one difference is that fork system call the PID is 0 and PID is greater than 0 for a child process and a parent process. But the parent process have the same address space as the child process to communicate easily with each other. By creating a process with a create process command, the child process have a new loaded program other than the parent's address space of memory. Here the parent process can wait for the child process using a wait for single object system call. Inside that the parameter is passed is the handle to the new process's threads. After returning for the wait for single object system call, the parent process can resume its operation like the previous one. So now we'll see with the help of a program that how Windows can create a process using a create process. Here we are declaring two structures, startup info and process information, and the instances of that as SI and PI. Now inside the zero memory function or zero memory system call, we are passing the parameter, the pointers to the instances of SI and PI and the size. With the help of that, the memory for the structures can be allocated. Now here we are using the create process command to create the actual child process. Here, as we have mentioned, that there are more than or at least 10 parameters in the create process command. The first two parameters are the process name and the command line interface. If the process name is null, then the command line interface will determine that what process is going to be executed. Here we are executing the mspaint.exe process. The mspaint.exe and its directory path name is given here in the command line interface. Now the next parameters are our default value using the create process command. What are they? They are the handle to the process, the handle to the thread, which are given here null. Again, the false parameter shows us that it is not the inheritance that parent process is giving the child process its address space. And by declaring 0, we are here in specifying that we have not created any flag. Now the next two null are specifying that we are using the parent's environment and the startup directories for the child processes. And the last two parameters are the pointers to the instances of the startup infrastructure and the process information structure. Now if the creation is failed, the create process cannot do anything but giving an error message that the process creation failed and returning any number other than 0, which is considered for a successful creation. Now the parent process is calling a wait for single object, that is a wait system call, as in the Unix. And the parameters are the handle of the process to the child process. Here we are specifying this parameter to telling that the window should wait for the parent process that the child process is executing, and after its termination, the parent process will resume its operation. By displaying the message child has completed, the displaying is done because the parent process is being informed that the child has finished its operation. Now as we are using a handle operation, so we must close the handle too. Now using the close handle system call, we are passing the handle to the child process and its thread too. So by closing the handle, we are declaring that we have finished the creation of process inside the creation process element. That is all for process creation. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.